Hi, everyone. Thank you so much for coming to our talk, From Snowflake Servers to Snowflake Clusters. My name is Allison Richardet, and I'm with a company called OCI, and we're working with MasterCard, and Fabio is with MasterCard. So today, there are a few things we want to focus on. Security, patterns, and common workloads that we can draw on from the patterns, and then GitOps and how it helps us to achieve our goals. And then finally, we'll go into some implementation details. These are hand embroidery patterns. In art, we want variety and uniqueness. We are drawn to imperfection, and we want new and different. However, we don't necessarily want this with servers. So some issues with this are they can be difficult to reproduce, and debugging and testing can be hard. Also, changes and upgrades are problematic and can cause breakage. Also, instances can become out of sync. And then it also can lead to environment mismatch. So typically we want dev, stage, and production to all match. And when we're dealing with Snowflake servers, this typically can be a problem. And finally, there's also lack of audit trails, so understanding how, who, and when a change was initiated. So we're really going to focus on patterns. That's a theme you'll see today throughout the talk. And how can we balance similarities with uniqueness? Snowflake servers are not a thing of the past. Now we have Snowflake clusters. And with Kubernetes comes great power and responsibility. When we began our journey, we spoke with application teams who needed to move legacy applications to containerized workloads. And many needed a dedicated cluster due to several constraints, first of which was regional requirements. So with on-soil requirements, an application needs to ensure that all of the data, all transactions, and anything associated with the application remains in a specific region. And then there are also security concerns. Our tenants need access to their own deployments, while at the same time not having access to another tenant deployments, or as well as the entire cluster. So with these constraints and the number of teams we're working with, some requiring hard multi-tenancy, we need to support tens to hundreds of clusters per environment. And finally, we really wanted to focus on developer experience and operator experience. This can be difficult, and we wanted to be sure that we had easy onboarding for our tenants and that upgrades and changes would not impact our customers. And we need resilient and reproducible infrastructure. So now let's talk about our vision and how we addressed this. So with security, we need tenant isolation. We have multi-tenancy, and in order to do this, we use namespace isolation and also utilize role-based access control. And then for those tenants who require hard multi-tenancy, they have their own dedicated cluster, as this is not currently possible with Kubernetes. And then we have common services that are based on patterns. And these are patterns that we found when we were speaking with application teams. And it's things like ingress, monitoring, logging, continuous deployment, tracing. So all of these common tools that everyone needs. And we need it to be easy for tenants to onboard. So the Snowflakes give us this opportunity, and we're able to draw on a pattern to find what everyone needs. So how did we make this vision a reality? Based on the patterns, we distilled our cluster types down to 3 different types. First, we have a control cluster. We have one per environment. It manages deployments, and it has global monitoring. Then we have single tenant clusters, which are for teams who require hard multi-tenancy. And finally, we have multi-tenant clusters for teams who are able to work with soft multi-tenancy. And deployment of our services, we needed to ensure it was automated, and GitOps helps us to achieve this. And finally, we want our tenants to benefit from our core base services that we offer. So we give them the ability to customize for their unique needs, for their unique pattern. So now let's discuss the timeline of our journey. In early 2018, we introduced Kubernetes to application teams. They were excited about the ability to control deployments and really wanted to learn more. They quickly realized that it was complex, and third quarter of 2018, application teams were seeming to be overwhelmed, and they were having a difficult time navigating the technology. Then in fourth quarter of 2018, we began to draw on the patterns we were seeing and consolidated the base services. We built in more automation, and we worked on creating scalable, redundant, and secure infrastructure. Then in first quarter of 2019, we worked more on tenant management. So we worked with tenant isolation, we extended base services, and allowed them to customize for their unique needs. So for example, a custom Grafana dashboard. So now let's have an overview of what GitOps is. GitOps is basically a couple different things go into the definition. So Git is the source of truth, and you have declarative definitions of environments, configuration, and deployments. So for our case, we use Helm for templating, and we use Kustomize for manifests. So in that transition from Helm to Kustomize, we use Helm Convert. And Kustomize is how we deal with Snowflakes. The patterns give us our base services, and then we use overlays to customize for tenants for things like ingress. And then all of this is stored in Git. Another part of GitOps is managing deployments from Git in an automated fashion. So we use a continuous deployment tool which manages our automated deployments. It ensures the declared and actual states match. And the tool we've chosen is Argo CD. So Argo CD is a Kubernetes controller, and it does a diff, basically, and looks at what is declared in Git and what is actually running on the cluster. And if there are any differences, it's able to reconcile that. So before we move on, I just want to get a read of the room. Who has used Kustomize? Okay. And then what about Argo CD? Okay. Well, hopefully for those of you who are new to these technologies, we'll give you a good introduction. And then those of you who are familiar with them, hopefully we give you some new ideas and some things to take home and back to your companies to work with. Next, I want to go into some background information of some tools that we're using at MasterCard. So for our infrastructure, we have PKS that we're utilizing. It is Pivotal Container Service for Kubernetes. We have 3 availability zones, and we're utilizing PKS, Bash Director, and Ops Manager. We have object and block storage spanning all availability zones. And then NSXT is our software-defined network. The PKS infrastructure has its own dedicated subnet, and it talks to the gateway and IP backbone, which has access to the entire network. So next I want to go into how we create clusters. And our cluster creation is based on GitOps. We add a cluster definition to Git. This kicks off a Concourse build. Concourse is an open source pipeline-based CI/CD tool. And then through the PKS API, a new cluster is created. We define the number of nodes, and by default, we have 3 masters, so we're fully HA. The system namespaces are created, so Cube system and PKS system. PKS system is a Pivotal-specific namespace. And each has its own subnet for communication with the gateway. We have the ability to set IP ranges and set up network rules as well. And the same goes for any non-system namespaces. So this is a strong foundation that we can use to build out single and multi-tenant clusters. Next, I'll hand it off to Fabio to talk a little bit more about our specific clusters and what we have running on them as base services.
Thanks, Allison. So, as Allison explained, we are building many clusters for our different tenants, and we run all this on-premise. So the first problem we're facing is how we're going to manage all these clusters, right? Because it's a complexity to manage one cluster from an operations standpoint. Imagine start to manage hundreds of those potentially. So we introduced this concept of control cluster, and we use this control cluster to basically have a single place where we can operate all the other clusters that are part of the environment. So for each individual environment, we always have a control cluster that bootstraps the environment itself. So for monitoring, we created a single pane of glass. So what we've done is we deployed a combination of Prometheus and Thanos. If you're not familiar with Thanos, Thanos is a component that allows you to do HA Prometheus. So you can deploy several Prometheus instances, and then Thanos will reconsolidate the data and deduplicate the data for you. So the Thanos that are deployed, are the same in all of these clusters, control or non-control. They will scrape data from Prometheus, which scrapes from everything else, and then they're going to send the data to our object storage. And in doing that, you can also set some of the data. You can change the basically retention, and you can downsample your data. So in that way, you can basically have the ability of retaining longer data for analytics later on. And once you do this, the Thanos on the control cluster also has the ability to go and read the data from there and provide, through Grafana, a single pane of glass for our operations. So we have set up Grafana's dashboards where you can go and choose and select all the different clusters that are part of your environment, so then you can basically monitor everything from that place. And it goes from both the core services we deploy to the tenant space where our applications are running. For logging, we did a very similar thing. So we deploy a fluent bit for each individual node in those clusters, and those fluent bit will relay data into an elastic data store that we have on our control cluster. So all the logs are going there. We have some logs we are not representing here. We have some logs that for compliance and go to Splunk. We can send those out there, but the majority of our logs are going to Elasticsearch. And again, that provides through Kibana a single place for people our operations to go and look at those logs. We also use our control cluster to have a unified CI/CD pipeline. So when you're going to go and do a change in Git, we basically have an Argo CD that listen to those changes in Git, to those applications and projects that we have referenced through Argo. And then Argo goes and automatically deploys both the core services that we defined and or custom dashboard or custom services that we've done. So if you're not familiar with Argo, Argo basically extends the concept of desired state versus actual state that Kubernetes has. So when you do a deployment in Kubernetes, Kubernetes is going to check what is really running versus what your deployment is saying it should run. And if there is a mismatch, it's going to go and bring up more pods or tear pods down or whatever is required. Argo takes that further upstream. So basically, it has a concept of what an application should be when it runs, and it matches the deployment. So if you do a change, let's say an image change, it will go and check if your deployment has the version of that image that you want to deploy. And if it doesn't, it's going to go and update the deployment, which then in turn is going to update the pods down the stream. So it's a very powerful tool, and we found it very useful for automating all these steps. Okay. Next, a little bit on Kustomize. I know this is not about Kustomize, but I want to just give you a flavor of what Kustomize does. So Kustomize has the ability of taking a base deployment YAML, right? And it can be any type of YAML deployments. It can also be on CRDs. And actually, that's what we do. We use customized resource definitions, as I will show you later. So you can clone a YAML file. You can build it as we do from Helm templates. So we leverage the community as much as we can, because there is a lot of good stuff around on, basing or foundation for deployment of applications. And then we write an overlay. And, Kustomize have many, many ways of doing this. A strategic merge, as JSON patch, and all sorts of ways you can write these overlays on top of it. In this example, I use a JSON patch. So it's very simple, right? It's a JSON path where you're going to say, replace something somewhere. So in this case, it's going to go and replace the Kibana generic name into actually a DNS fully qualified name that will be used for a hypothetical cluster. The same thing can be done with the host itself. So, and you can write as many as you want of this. They can go and change and modify whatever parts that you want of your deployments. Once you've done that, basically you do a Kustomize build, and actually Kustomize now is part of the kubectl, has been fully integrated. But Kustomize will do a build, take your base application that you reference, apply the overlays that are relevant for what you are deploying, and build a new YAML file or multiple YAML files as a result, and those will be applied by your kubectl. In our case, we don't use kubectl, but we use Argo. So then Argo integrates us with Kustomize. So basically, when Argo needs to check if an application is up to date or not, it's going to go ask Kustomize. Kustomize will build the thing for Argo. Argo is going to check the desired state versus the current state, and if it's needed, it's going to push those YAMLs into Kubernetes, and then Kubernetes will take from there. So let's go a little bit more in the details of how we build a cluster and auto-provision. So the goal here for us is application comes in, they want the dedicated cluster, they can choose among a kind of set of a la carte services that we provide, and then they put that in Git, they make a Git request, and from there on is 100% automated. We don't touch it. So let's start. So they go and they make a couple of files. They usually request a cluster, and then they request the a la carte services. So you see these are CRDs, custom resource definitions that we introduce. And we are actually looking actively now at the cluster specs, which came out recently. And we want to follow that and see how that progressed, because we see a lot of overlap with what we are doing. But the bottom line is that they're going to create a CRD. I know people use CRD, most people know CRDs in relationship with operators, but we are taking this with a slightly different spin. So it's a way of expressing what you want in the environment. And then when that's done, Concourse is listening to those GitHub repos, and it's going to basically come up, talk to the PKS API, and then PKS can provision a cluster. So when a new cluster is done, Concourse will do a last part, which is we'll start in our control cluster a Kubernetes job. That Kubernetes job will basically go and operate on the Git. It's going to clone the Git repo, and it's going to go and create a new customized deployment. That customized deployment is based on both information about the cluster itself as well as the general mapping, because as Allison said, our application teams want the logging, the monitoring, so there are a part that is common, and there is a part that is the a la carte, or some of the services that are relevant for them. And so the job will end up building these customized templates, which reference to the application definition, which are basically the basic definition, YAML definition to deploy Thanos, Prometheus, the logging, and all these kinds of guys. And once this is done, basically the job is going to tell Argo that now this new application exists inside the GitHub repo. At that point, Argo points to those, and of course, what it's going to do is going to see that none of these applications are in the cluster that's been created because it's brand new, and for that, like the desired state is not the same as the actual state, so it's going to go and start to deploy everything that has been requested. Okay? And you're going to deploy the core stuff as well as all the a la carte services. So let's go a little bit more in detail of what we've done with the different CRDs. So let's start from the cluster spec. This is very simple. I apologize to put YAML here, but I couldn't refrain from doing so. So it's very simple. Basically, we define the type of cluster you want. You have a name. You have a URL for it that you want to give it. And then there is the part very interesting beside the plan and the number of nodes you want for this cluster. We define a concept of a cluster type and the ability to inherit. So there are other types that will be defined. So let's say this is a car loyalty fake example. You want to be a single tenant cluster, which will mean some of the stuff that are part of that core constituencies will be bringing into the cluster. And then you deal with PII data and you want to be PCI compliant. And that will bring different type of applications by default into the cluster before this particular application team will deploy their own workloads. So in the customized deployment, we are creating variables, so we can use those variables to then use them, inject them into the overlay, so then the deployment of those monitoring, logging, and other stuff will be directly related to that particular cluster. So mapping. So this is the other part to the equation, right? What we're doing here, we're saying, okay, what applications, what a la carte services you want to bring as part of your own definition. And so we have the a la carte one, where these are part of the two original CRDs that the application will submit, and they will basically say, well, for my particular one, I need this storage service or queue service or whatever it is, which are part of the core services. But there is also a bunch of existing services that, as I said before, will be based on the types you inherit from. So let's say if PII, PCI, single tenant, and we also have a concept of core, which is like, it doesn't matter which type of cluster you deploy, which type of application or what type of service a la carte you want, we're going to deploy anyway, because these are for our own usage to basically manage and run those clusters. So when all of this is done, the customize is very simple, because now what you do, you bring in those base deployments, you bring in the cluster definition that they have created, and those overlays will bring in the app definitions, and they may have certain set of customized components in it that needs to be adapted for that particular cluster. So for instance, looking at logging, what it can happen, the Kibana ingress for that particular application may have a replacement operation. And this is very similar to the example I showed you before on purpose. Now you see though that the real thing is transforming with a bunch of variables that are inherited from the cluster definition and the mapper definition. So app name, cluster name, and qualified domain name are coming from those CRDs. So I don't have to constantly change my deployments or make my deployments tailored to a particular cluster or to a particular application, which will require manual intervention. It's all taken from templates and variable, and is all injected at the time of deployment. Okay? That is what allows us to basically don't touch anything and let this cluster be built. And lastly, if you guys are familiar with Argo, this is a very typical definition of an Argo application and deployment. And again, we inject variables in it. We have the application name, the cluster name, so we can make those applications in the metadata specific. So when we retrieve it from the log, we will know which application they belong to, which cluster they belong to in that particular environment. And with this, I'll pass back to Allison for the future plans.
Okay, so you've seen a bit of our journey and where we've come from. On the left, it's sort of grayed out. That's where we are, where we've been. And moving forward, we want to share some of our future plans for our journey. So this quarter, we've been working a lot on improving onboarding and improving the tenant experience, and also making enhancements to automation. Next quarter, we'll be rolling out an application, which is a UI for tenant onboarding, which will greatly simplify the process and allow them to select some custom dashboards and then other customizations for their unique pattern. And then finally, the end of this year, we plan to be back at KubeCon in the US to present some updates and then also share this tool we will be rolling out shortly. We started the talk with a focus on security, patterns, and GitOps. Hopefully you've seen this throughout the talk and have learned some things that you can take home. We think it's very important to identify security concerns and requirements upfront, as this can have a big impact on your journey and where you end up going. We also focus on patterns, and we've drawn on the patterns to find unique needs and also needs that are universal for our application teams, for our customers. So these patterns have helped us limit the types of clusters, also limit the differences between the types of clusters. And we've been able to come up with base services that all teams can benefit from, while also allowing them to customize using overlays for services. So we provide a platform and a product. How can we best enable our customers? And then GitOps. We're using declarative definitions in version control and have automated deployments with a built-in audit trail. So if we update an image in Git, the change is merged, and then all clusters running this are automatically updated. This is pretty powerful. And then with the CNCF, you've probably noticed a lot of the tools we have discussed throughout this talk are open source. Many of them are part of the CNCF. This is a known road to success on our cloud native journey, and we really feel it's important to embrace that. And as well as taking advantage of that, we would like to give back to the community as well. Additionally, we'll be leveraging some technologies, including the cluster API and the multi-tenancy SIG, and feel it's good to draw on the community and research and usage in the community, as well as giving back. So thank you so much for coming to our talk. Hope you enjoyed it, and let us know if you have any questions.
We have a few minutes for questions. Oh, sorry.
Hi, thank you very much. How do you manage secrets and config management in this kind of pipeline with Argo? So how you inject these secrets and this config management and variables in runtime?
Yeah, good question. We inject the secrets at the beginning with Concourse. I didn't show that part. And we basically have a vault for each individual environment. So we have one vault per environment. So we bootstrap the secrets that we use for our own core services. We don't manage right now the secrets for the application. They manage it themselves. Okay.
How you extract these secrets? How you extract the secrets from Concourse? So what is the backend?
No. Concourse basically bootstrap the secrets into Vault.
All right. Okay,
and then the application have a one-time token. When they come up, they're going to talk to Vault and retrieve the secrets. And we use a path that is similar to the deployment structure in Kustomize in Vault, where the secrets are stored. So if I am app A / blah, 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 that's the equivalent path will be my Vault path to find my own stuff. Yeah.
So how granular do you go into the Git repositories? Do you have a big one where you have all the clusters defined, or do you have small Git repositories which Concord just checks all of them?
So right now we have several different repositories. One where we have environments, we have base applications declared there. Then we have a tenant repository where all the tenants have like we have their role-based access control and different security set up for managing tenancy. We have our clusters defined in one repository. Am I missing? I know I'm missing some.
No, but basically we have one repository for environment. So the environments are divided, dev, sandbox, stage, and then inside there are the clusters. So we don't have one repository per environment, we have just one. And then we classify the different deployments, the different environments right there, yeah.
Can you talk a little bit more about how you automate all the infrastructure for those clusters? Like you talked about the APIs that you have, but are you leveraging any tools like Terraform or stuff like that for all the infrastructure that's there?
So as Allison said, we are using PKS, the Pivotal solution. So Pivotal has basically is built on their Bosch foundation. And through the API, you can request the creation of a cluster, which will talk to vCenter, create the VMs, and then deploy the core components, the Kubernetes pieces into it. So we are not using Terraform. It's all delivered as part of the PKS platform.
Okay, and just one follow-up. Sorry? Can you hear me? 1, 2. Yep. No. Nothing.
Hello?
Hello? Yeah, they're all dead.
So in your deployment flow with Argo and everything, do you always deploy the infrastructure and then all the application code all together at the same time, or are those separate flows?
No, they are at the same time, in the sense that what we deploy are the core services. So basically, imagine that you are coming to us and you say, I need a cluster to run this application or applications, and you are one of the business units. So we will build the cluster based on the type of cluster you require. We'll provision the cluster and deploy all the core applications, core services that are needed for managing the cluster and for you to extract metrics, logging, and this kind of stuff. And then we're going to tell you, like, the cluster is ready, then it's up to you to go and deploy the applications. We have a completely separate... Yeah, sorry. It doesn't seem to work either. Yeah. So, so we are basically let the application team then come in, and we have a different pipeline for building applications that we have from building the...
Are you getting audio?
Yes. Audio from its back audio, not from the microphone.
So the question is, how do you solve deployment dependencies? Or the order of deployment, right? It's hard to hear.
So are you asking how do we solve the deployment dependencies, if any? Okay.
Yeah. Okay, so...
check. Yeah.
Kustomize is able to order deployments based on whatever is needed first. It knows that.
Yeah, so Kustomize will...
Kustomize handles that.
Yeah, we'll figure it out the order. We will not basically create, you will not inject a namespace creation at the end. It will make sure that the order is preserved based on what you need to do, right? So if I define a namespace, the namespace will be at the beginning of my YAML, and then everything else will be in the right order for that service to come out. So it's all done by Kustomize. We can take it offline.